Hi students, today I am going to discuss the three-dimensional reflection in computer graphics. In last videos I discussed about the 3D translation, 3D rotation and 3D scaling concept. Now I am going to discuss the 3D reflection in what the reflection is. The reflection is a kind of rotation where the angle of rotation is 180 degrees. So the rotation can be taken on the x-axis and y-axis and z-axis, but here the combinational of the x, y, z can taken place in the 3D reflection, 3D reflection, because the reflection can be taken in exactly the 180 degrees. In two-dimensional, we also observed the 180 degrees can be taken whatever the x-axis of the reflection object. So the same object can be located in the mirror method. Using that mirror method is nothing but the image can be displayed in the opposite way. So here the reflected object is always formed the other side of the mirror. So we know that is similar in the two dimension. Again, the size of a reflected object is the same as the size of the original object. So in the 3D reflection also, the image size cannot be modified. So the same size is a reflected object is similar to the same size of the existing object, that is the original object. So now in some of the notations in the three-dimensional reflection is, so here consider the point object O that can be reflected in the 3D plane. The initial coordinates of the object can be defined as the x volt, y volt and z volt, and the new coordinate of the reflected object O after reflection is nothing but x nu, y nu and z nu. So in 3 dimensions there are 3 possible types of reflections are taken place. The first one, the reflection relative to xy plane. Second one is the reflection relative to yz plane, and third one is the reflection relative to xz plane. Now these three are the considerable types of the reflection in 3D plane. Coming to, we detail discuss about the reflection takes place on xyz, and reflection takes place on the yz, and reflection takes place on the zx. Now we are going to take the reflection relative to xy plane. Now the xy plane, that means the reflection relative in the xy plane, in the sense there is no impact on the x-axis and the y-axis. So the impact goes to the z-axis only. So that means the x nu value equals to the x volt value, and y nu value equals to the y volt value, and the z nu equals to the minus z volt. That means here only the negative sign is taken place to the z-axis only. That means x and y values doesn't change in the reflection relative to the xy plane. So the reflection is completely on x and y combinational plane. Then there is no impact on those two, and the impact goes to the z-axis. Now we are going to take that homogeneous matrix order of 3D reflection is here. We can observe simply. So this is an finding the x nu, y nu and z nu values with combination of the unity, that is the one isolation matrix, that equals to. So we have to observe here only the minus indicates here, that is the z value. The z value is only to the minus value. The remaining all are the x and y values are the 1 1 similar values, and the remaining is the zeros. So we have to take the homogeneous matrix. So that's why we can take the diagonal elements we have to observe as the 1, except the z value. So all the values are the positive, only the z value indicates to the negative, because so in the xy reflection, so the impact goes to the z-axis. Similarly into, so we know that the matrix order form. And so what exactly this particular x nu, y nu, z nu and 1 equals to the matrix into x volt, y volt, z volt and 1 value. So this is the reflection relative to the xy plane. Now coming to the reflection relative to yz plane is, so this reflection is taken place on y-axis and z-axis. So but there is no impact on the x-axis. So there is an impact on the x-axis, there is no impact on the y and z plane. So here the reflection goes to the yz. So the reflection takes place on the modification takes place on the x values only. The y and z values are similar. That's why here the x nu equals to minus x volt, and y nu equals to y volt, and z nu equals to z volt. So similarly we can write the homogeneous matrix for 3 by 3 order of the yz plane in 3D reflection matrix is, now you can observe here in yz. So the impact goes to the x value, that why the negative sign is taken place by the x value. So that's why here the x value is -1. Now you can observe here, so the xy value is the -1 and the remaining or the zeros, and you can take the diagonal elements, all are zeros in the homogeneous matrix. So similarly that is multiplied with the x volt, y volt and z volt with the unity 1 value, that is 1. So this is the reflection relative to yz plane. So that means the reflection takes place on yz plane. So there is no impact on the y axis, there is no impact on the z axis. The impact goes to the x axis, that's why where x nu equals to minus x volt value. And similarly you can observe in the reflection relative to xz plane. So this is the third combinational one. So the values will be identified like this. So here you can observe x and y and z values you have to consider. So the combinational of the xy, the combinational of the yz and the combinational of the zx. So these three are the possible ways to take the plane. So now we are going to take the last one, that is a zx. So now what the reflection relative to the zx or the xz plane is nothing but there is no impact on the xz and the x axis and the z axis. The impact goes to the y axis. So that's why the y nu equals to minus y volt value, and the remaining x nu equals to x volt and z nu equals to z volts. So here in the particularly the reflection relative to the y x z plane, there is no impact on the x and z plane. The impact goes to the y plane only. The y nu equals to minus y volt. Now coming to the homogeneous matrix, for this you can observe in this matrix the only one value indicates to the negative value. So which one is affected? That is the y value is affected, the y axis is affected, that's why the y coordinate becomes to the -1. The remaining all are the diagonal elements are the ones and the remainings are the 0, and which can be multiplied into x volt, y volt and z volt 1. So finally we can observe in the reflection relative to the both three axes, the combinational axis of the first one is the xy and the yz and the zx. So these three are the different one. So when we take the two combinational reflective, the third one is the affected. That's why the reflection takes place is the entirely different one we have to be considered. Now we go through the problem. Here we can observe in the 3D triangle coordinates. The triangle is nothing but the three coordinates are the given ABC. So A indicates 341, B indicates 642 and C indicates 563. So now applying the reflection on the xy plane only. Now it will be concentrating only on the xy. So we already discussed if the reflection takes place on xy, so automatically the impact goes to the z. So that's why here the z value is the negative automatically. So what the coordinates are given here, a value 341, and for each and every coordinate we can find the new coordinate value. So with the application apply of the reflection on the xy plane. So in the apply of the reflection on the xy plane, so the value becomes to the change the same values of indicates the x and y value, and the z value will be taken as the negative, that is 34 minus 1. And similarly you can observe for coordinate b of 642, the negative sign will be considered to the z value, the remaining are the same, because in the xy reflection the impact goes to z, there is no effect on the xy value. The similar x nu and y nu is the x volt and the y volt value. So that's why here the new coordinates of the b after reflection equals to 64 minus 2. And similarly we can find the coordinate c to find the new coordinates apply to the reflection on these two. then we can identify x new equals to y volt, y volt, and y new equals to y volt, and z equals to minus, because this can be impacted on the z value, that's why it is minus 5 6 minus 3. So finally we can derive the new coordinates of each and every given triangle coordinates of the object. So this is the concept of the reflection. What the reflection is, a reflection takes place a kind of rotation, so where the angle of rotation is 180 degrees, so which may be considered to be a mirror method. So whether that object is a rotation in a particular angle of the plane, so the angle can be taken in the combination of xy plane or the yz plane or the xz plane. So this is the 3D reflection. In the next video I am going to take the one more transformation technique.